Today, I just wanted to go over a little more details on how to get an efficient Joule Thief going. And I guess by efficient, I really mean just a very low power Joule Thief going. And this is mainly for if you want to run like an LED, for example, off of a capacitor or something like that. So just for example, you can see I got this guy going. It's teetering on about 10 microamps. I'm running it from this rechargeable AA. It's just a little green pre-wound toroid down there that I got from a power supply. But just to start off with, I would always recommend creating a little test rig. So you see here, I've got this little rig set up with my Joule Thief connections just on clip leads, so I can just kind of swap it out. If you don't do that, it's just going to be a very painful effort of doing your testing on your Joule Thief, playing with clip leads and all this and that, and I'm done playing with breadboards. I'm telling you, these guys piss me off. I'm done using these. I mean, a lot of people use them, but just the whole using these little jumpers. Unless you got really good jumpers, I would imagine. Every now and then you're playing this game where something's not working, and you're like, "Well, let me try tapping this guy," or if I wiggle this guy, it'll start working. And you'll eventually realize, "Oh, I had to wiggle some shit to get it to work." Anyway, I don't use those guys no more. But essentially, what you want to do is just something like this right here, and I found this to be a relatively good setup. So you see, I basically just got my Joule Thief connections here. This is where I would connect my pre-wound Joule Thief. You know, you've got your positive and base and collector. And on the base, I've basically just got a 1 mega ohm and a 10K pot in series. Except on the 1 mega ohm, I've got my little tank cap here. And what I usually use for that is one of these small capacitors that are labeled 104 on the outside. They're very, very common. You can find them all over the place. I can't remember the exact value of that. Works pretty good though to get a low draw oscillation. And you see, basically that just gives me a wide range of varying the bias on this transistor, so I can try to find a nice little tank going on here, and then I can fine tune it with this 10K. And you also see it if you want, I got like a switch on mine right here, and then I basically just bridge the switch with I like to use these PC power supply connectors because meter probes fit in there nice, and just it's worked out over the years. So you can do that. I recommend doing that also. You can just kind of plug your meter leads in there along the switch, bypass the switch. Now you can get an easy current draw. So that's the setup that I would use and recommend. Of course, as usual, I've got my LED load with polarity across the collector and emitter. So basic Joule Thief type deal there. And you can see here, let's see, one thing to note, I'm using an auto ranging meter. And the reason I'm using an auto ranging meter is because not only does my camera suck and doesn't focus like it's supposed to, but when you use when you use a meter that you have to set the range, you're basically changing the capacitance in this meter. You're changing a capacitor in there somewhere, so to speak, so it's throwing the circuit off. So I'm just using this automatic ranging just for simplicity. But at any rate, right now this guy was running about 10 microamps, and that's all because of the tank cap right here. So I can ultimately tune it to a region where I get the good light at a low cost, just by tuning this per any regular Joule Thief. But using this capacitor, I can also tune it way down to the point where, while this may ordinarily still oscillate, it's probably not going to show you light from the LED until you add that capacitor. So just for an example to see how this guy works, let's tune this up. So all the way up, I'm getting about 136 milliamps draw from this guy all the way up. And see, I can tune it down to about 40 milliamps and get roughly the same brightness, because I was actually overdriving it before and it was very inefficient. So that general range, I can use my 10K pot to kind of fine tune it, so you can see roughly from about 8 milliamps up to about 40 milliamps. I get a really good brightness from this LED with a good little adjustability there. So this will operate like this without this capacitor. It'll just be a little different set of resistances here. But this is roughly the performance I can get from this toroid, and that's pretty good. It's not bad. So I would say, from about about 20, I would say about 25 milliamps. I get the really bright LED from the 1.3 volts, and it's not a bad deal. But if I really wanted to, I could still get, you see right there, that's not bad. We're at about a milliamp. If I go up to about 5 milliamps, that's still pretty decent light right there. And I can bump that all the way down in this range from about 250 microamps to about, 5 milliamps. So that's my range here with my fine adjustment. Okay. Now, so just to show what this tank cap does, though, let me go ahead and take that out. When I take tank cap out here, right now it's not making all that much of a difference. But when I cut the circuit all the way down, or when I turn the resistance all the way up as high as it'll go with both pots here. See, right now I'm drawing about 90 microamps, but we don't get any light from the LED. So let's see where I need to crank this up to where we actually do get light. So it takes about, it's not until around roughly 500 microamps, half a milliamp, that we see visible light in this LED. Which, I mean, I'm not going to complain about that. That's pretty good. But let's just say if you wanted to run this off of a capacitor, you're going to need a super cap. But if I wanted to run it off of a regular, let's say, electrolytic capacitor, I don't have any super caps myself, then throw that capacitor in there, and now you can see we've got some sloshing back here. It's not necessarily sloshing, but I mean, it's just the pulsing of this LED, but there actually is some sloshing going around more efficiently. You can see that we have the light. So, I don't know what percentage that is, what, 50 times better, I don't know, but before it took about 500 microamps to see steady light. Let me bump this up till I see just barely steady light here. So there, to my eyes, is not blinking anymore, and we're about 30 microamps as opposed to 500. So that's the difference right there, and that's like I say, it only makes that real difference in the lower levels. I mean, it all depends on what variables you have going on, but let's just say with this particular toroid, this particular circuit, it only makes a difference at the lower levels like that. So I could run this from a capacitor now if I wanted to, electrolytic capacitor or something like that, because it's only running from about 10 microamps. So I'm gonna let's try another one of these guys. And here's actually another green one like this one, this larger one that was pre-wound, and I know that works actually pretty much the same. So let's see. Here, let's try this yellow one. This is a fairly common uh, toroid that is pre-wound in a lot of power supplies. But, oops, so let's hook that up and then see what happens. All right, so now we got this guy on there, this yellow toroid that was pre-wound, and I actually was under the impression those yellow ones were pretty good, but looks like this guy is not. Let me see. Right now, 90 microamps, no light. It's fairly expected. And as I'm cranking it up here, it's a very gradual increase in microamps here. I'm already at over 5 milliamps though, and I don't see any light. So this guy actually kind of sucks. Let's see if I can kind of fine tune it here. Right about there. I have to pull over 60 milliamps before I really see any light here. Yeah, so I pretty much have to pull about 100 milliamps or more to get that brightness. I don't know if this. Let me see what this capacitor does. Can't say that's going to make a whole lot of a difference here. Oops. So it helped a little bit. So I can actually start to see a little bit of light coming out here. A little flicker there around 7 milliamps. Another around 8 or 9 milliamps. It starts coming out. A little bit more around 11. So I don't really start to get. Now I can get some good brightness around 35, 36 milliamps. So it made somewhat of a difference. But I'm maxing out. I can max out at around 75 now. So generally, I'm not liking this guy right here. So let's take this guy out and try try this one that I wound. All right, got this guy in there now. Let's see, and back to drawing 90 microamp switch. Let's see. Whoops, put this on here. Now I know this meter gives me pretty similar readings to the other meters I've tried, but like I said, this is auto ranging, so it just makes it a little easier. But the fact I'm actually pulling this 90 microamps right now is making me wonder, is that that's what it was pulling in the last one. So maybe it just so happens it's oscillating right now because I can't turn my resistance up any higher than it is, and it just still wants to oscillate, but I don't see any light here. So matter of fact, I can find out real quick. We'll put this capacitor on here. So something's going on in this circuit that I need to figure out, where I've got a parasitic draw here that I probably shouldn't have. But anyway, not that big of a deal. So right now, this guy, really don't see the light. Let's see. Yeah, so it's about over 50 milliamps before I start seeing some light on this guy. So that's really not good either. All right, so as usual, Let's throw this capacitor in there. Alright, now that we've got the cap in, I'm not getting anything from what this says is 90 microamps, but start to get just a little bit of light here with about 100 or so microamps. So that's obviously much better. Tune that up. Still get a blink. Let's get rid of that blink. Let's see what we can draw here. So got steady low light, still under a milliamp, half a milliamp. As we crank it up here, you see get some pretty decent light, around 5 milliamps. And then can bump it up. Wants to draw about 160, but I can get this about tuned in, about 80 milliamps. So that was similar to one of those other ones I tested. So this is that was about 75. I got the good light. This was about 80, which is not bad. So that's about an average Joule Thief. But the last one I want to try is just going to be this one right here, which is very similar to this first one I used. So these are two green toroids here that came from the same power supply. Obviously thicker windings, bigger core size. Just want to see what that does. So put that on there. Alright, so now I got this guy on there. Also changed out my meter, my ammeter here, to this guy, which I can put on the 200 microamp scale. But you can see it's showing me the same little parasitic draw as my other meter, which is roughly 90 microamps. So I might need to change out this transistor, or maybe use a different transistor for this test circuit here. But just to get that out of the way, so this this meter's not whacked out, it's giving me the same little parasitic reading there. And you can see, let's see, I don't have my little tank cap in there. Well, 0.3 volts. So when I bump this up, let me switch this over. So about the 2 milliamp scale here. I can actually see light from around half of a milliamp, which is pretty good. So these green guys, I like these green guys. And it actually, about 2 milliamps. See pretty decent light. Let's put this in the 200 milliamp. So see how changing my ranges here is changing the circuit output here. So we're at about half a milliamp, see some light. About a couple milliamps, get decent, really usable light, and crank it all the way up, get better light, about 10 milliamps. Then at about 50 or so, you get that good. I would say that's what I would call my little max out range right there. So boom, about right there, and I can kind of fine tune that. So yeah, roughly about 40, 50 milliamps. I'd say roughly about 50. That'd be a good one right there. So about 50 milliamps, 1.3 volts. That's when you get the really good light from your 3-volt LED. This setup. And even so, without any type of tank cap in here, to be able to get that very faint light from under a milliamp, that's pretty good. That's pretty good. And that actually, that'd be usable at night. I could walk around and navigate with that. So there you go. But Crank it all the way down where you don't see any light. All we're getting is this very negligible parasitic draw. Let's put this tank capacitor in there, which actually gets rid of that. See, when I put that tank cap in there, actually bumps that draw down to about 40 microamps, according to this meter here. And I have light, very, very dim light, which if I turn up, see, it's actually took a little downward slope there. Keep turning it up. Let's see. Let's put it in another scale there. Keep turning it up. Get about get about roughly the same deal, around 500 or so microamps, not bad light. Then up in your 2 milliamps range, you get your pretty usable light there. Obviously, bump it up even higher. Let's see. I find my good quote max out right here. Right. So with this capacitor, I'd say I get a pretty good deal right there at about that's about the same, right? So about 40, maybe 50 volts there, or milliamps. But once again, just runs more efficient at lower voltages and inputs with this tank cap here. So ultimately, my conclusion is I haven't noticed much of a difference as far as running this LED load between this guy and this guy. That is a difference I may end up noticing if I try to run a much larger load. For example, more of these LEDs in parallel, where I might find I need more a larger core to be saturated like this guy. But for this particular load, I have no need to use anything bigger than this. I could actually go a lot smaller than that. But, you know, if I was trying to design one that's going to run maybe like a motor or something like that, I would probably want to go with this guy. But